CBSE Class 9 Math Extra Practice question. This question is from the topic Surface Areas and Volumes. In this chapter, we are going to be focusing on the curved surface areas of cylinders. That's the focus of this question. Let's get started. It's an easy question. A rectangular sheet of steel of length 1056 inches and width 15 inches is cut along its length into smaller rectangular sheets of length L inches and width 15 inches. We are retaining the width, we are cutting it along the length into smaller rectangular sheets of length L inches. Each of the small rectangles is rolled into hollow cylinders of diameter 28 inches and height 15 inches. We are picking each of the smaller sheets, rectangular sheets that we get, we are rolling it into cylinders of diameter 28 inches and height 15 inches. What we need to find out is how many hollow cylinders resulted from this operation. It's a very simple, straightforward question. Let's get clarity on what is happening to this long sheet, right? So this rectangular sheet, let's say this is a sheet that we have. Length of the sheet is equal to 1056 inches. Width is equal to 15 inches. We are cutting it along its length. So we're going to make small rectangular pieces, each of length L inches. What do we have to find out? We have to find out how many hollow cylinders resulted. We are picking one such sheet, making it into a hollow cylinder. So number of hollow cylinders that we'll get will be the same as the number of these small rectangular sheets that we have got. Total length is equal to 1056. Each piece that is cut is of length L inches. So how many pieces will we get? We'll get 1056 divided by L. So that is going to be the final answer. The number of sheets that we would have got, smaller rectangular sheets that we would have got is 1056 divided by L. So the objective is to find out the length of each of these smaller sheets. How do we go about it? Take a look at this. This is the rectangular sheet. Length of the sheet is L, width is equal to 15. We are rolling it into a cylinder. I got a cylinder whose diameter is equal to 28 inches and its height is equal to 15. When it is kept as a sheet, the area is length into width. We are essentially talking about a rectangle. When it is folded and curved into a cylinder, the area of the sheet essentially is nothing but the curved surface area of the cylinder. So the way we are going to solve this question to find out the value of L is equating the area of the rectangle to the curved surface area of the cylinder. Area of the rectangle is of length L, width is equal to 15. So area of the rectangle is equal to length into width, which is length times 15. It is folded into a cylinder. The height of the cylinder is equal to 15. Diameter of the cylinder is equal to 28. Curved surface area of the cylinder, we know the formula is equal to 2 pi RH. Take pi to be equal to 22 by 7. So the curved surface area, which is the same as the area of the rectangle, is 2 times 22 by 7, which is pi. Diameter is equal to 28. So radius is equal to half that, which is equal to 14. 2 pi r, which is 14, and height is equal to 15. 7 gets cancelled with this 14 to leave us with a 2. So what do we have here? L times 15 is equal to 22 times 2 times 2 times 15. Both sides of the equation have a 15. Let's divide it by 15. So the value of L will be equal to, if I divide 15 gets cancelled with 15, will be left with L is equal to 2 times 22, which is 44. 44 times 2, which is equal to 88. So you found out the length of each rectangular piece, which is equal to 88 inches. We need to find out how many such rectangular pieces we have. That is equal to 1056 divided by L. 1056 divided by 88 should give us the answer. 88 into 10 is 880. 88 into 2 is 176. 880 plus 176 is 1056. So this is equal to 12. So the number of rectangular pieces that you have got is equal to 12. The number of cylinders that you have got is also equal to 12. Right? A very simple, straightforward question. Equating the area when it is kept open as a rectangular sheet, and when it is folded, it becomes a cylinder, the curved surface area of the cylinder. That's how we got to the answer. Quickly recap it for about 30 seconds in a printed form. Data given to us, large rectangular sheet, 1056 inches length, width is equal to 15. Small rectangular sheet, width stays at 15. The length of each sheet is equal to L inches. Diameter of the cylinder that we are making is 28 inches. Height of the cylinder is equal to 15 inches. These are all the data given to us. The number of hollow cylinders created, which is what we need to find out, is nothing but the same as the number of small rectangular sheets that we got by cutting this 1056 inches long sheet. So all that we need to find out is the number of such small sheets that we are able to make. How do we go about it? Compute the length of each such small sheet. So 1056 by the length of each small sheet will give us the total number of such sheets made, which is going to be the answer to the question. So how are we going to proceed with that? The idea for that is that when it is kept open, it's a rectangular sheet. When it is curved and rolled, it becomes a cylinder. Area of the rectangle is equal to the curved surface area of the cylinder. We're going to find out the curved surface area of the cylinder. Formula is equal to 2 pi RH. We know pi is equal to 22 by 7. Diameter is 28, so radius is equal to 14. Height is equal to 15. We solve and we get the curved surface area to be 88 times 15. Do not bother finding out this value because we know for the rectangular sheet the width is 15, so it's going to cancel out. So there's no point doing the calculation at this point. Quickly find out the area of the rectangular sheet, which is L times 15. Equate the area of the rectangular sheet to the curved surface area of the cylinder. So L times 15 is equal to 88 times 15, or L is equal to 88. We know the length of each small rectangular sheet. How many rectangular sheets will we be able to make? 1056 divided by 88, which is equal to 12. That's the answer to the question. Leave your feedback about this question and this method of teaching. We would like to hear from you as to whether this is useful, whether you got value from it, and how we could make it more engaging and useful to you. Best wishes.